This video is for lesson 30-1, areas of rectangles and parallelograms. Learning goals are to solve problems using areas of different shapes and to be able to work with areas and perimeters on the coordinate plane. The real-life scenario for this lesson involves a company that makes tabletops of different shapes, and they need to figure out what to charge their customers based upon the square footage or area of the tabletops. So here's an example. Let's say the company creates a tabletop in this L shape here, and they want to charge the customer $8.50 per square foot. They would need to find the area of this in order to find out what to charge. This is called a composite figure. By itself, it's not a triangle or rectangle or parallelogram, but it can be separated into components that are those shapes. For example, one way to divide this would be to just draw straight across here. This creates a small rectangle on the top, a larger rectangle on the bottom, and then we could find the area of each piece. To find the area of a rectangle, we need to know the formula. It's area equals length times width. I'm using the letter A to be the word area, the letter L to be length, and the letter W to be width. For our top rectangle, this would be 3 times 2, which makes 6 square feet. For the bottom rectangle, using the same formula, we would go 6 times 2, which is 12 square feet. Therefore, the total area is 6 plus 12, or 18 square feet. This company would then multiply that area by $8.50 per square foot to find out how much to charge the customer. Now go to the next page and look at number 3. Here's another tabletop shape that the company produces. This is shaped like a parallelogram, not a rectangle. Some measurements are given. To figure out what to charge the customer this time, we would need to find the area of this shape, and the formula for area of a parallelogram is base times height. I'm using the capital A for the word area, the B for the word base, and the letter H for the height. The base of the parallelogram is how long is this side here. It is 3 feet. And the height of the parallelogram is how long is this dashed line. It is 1.5 feet. Multiplying these together, this is 4.5 square feet. The company could then multiply that area by the $8.50 to find out how much to charge the customer. So far we've discussed how to find the area of a rectangle, length times width, and how to find the area of a parallelogram, base times height. Here are 2 formulas that you need to memorize or put on a note page. Next, number 4. This company that makes the tabletops designs their tabletops using a CAD program, or a computer-aided design program. It draws the blueprints for the tables on a coordinate grid. So let's say that this rectangle represents the tabletop, and we want to find its area to know how much to charge the customer. The formula stays the same. Area equals length times width. Then figure out the length and width of the rectangle from the grid. Across the bottom, it is 7 units long, and going up and down, it is 3 units tall. You can get the 7 by counting the squares or by using the x-coordinates. If you find the difference between this x-coordinate and this x-coordinate, you get 7 units. To find the width, you can count squares or find the difference of the y-coordinates. The difference of a 5 and a 2 is 3 units. Anyway, the area of this is 21 square feet. Multiply that by the $8.50, and you would know how much to charge the customer. So far, we've discussed finding the area of a shape. That is, how much space is inside the shape in terms of how many squares a shape can be divided into. For the rectangle that's drawn on the grid, if we divide it into 1 unit by 1 unit squares, we found out that there are 21 squares in that shape. That is its area. Another measurement concept that you're often concerned with two-dimensional shapes is perimeter, the distance around the shape. So for this rectangle, we could find the perimeter by taking twice the length plus twice the width. That is 2 times 7 plus 2 times 3. That turns out to be 20 feet. Counting around the outside, it's 20 feet around that tabletop. This perimeter formula for a rectangle also needs to go on a note page along with your area formulas. From the examples we've done, we can see that it's very straightforward to find the area or the perimeter of a shape if we have a drawing of the shape and the measurements that we need. Let's try number 5. Here we have the 4 corners of a shape, but we don't have the shape drawn yet, and that will make it harder to find the perimeter and area. Let's draw the shape. -3, 4 is located here. That's point F. 2, 2 is located here. That's point G. 2, -4 is located here. That's point H. And -3, -2 is here. That's point J. Now we can connect the brown dots. The reason that drawing the picture is helpful is it allows you to know what shape you have. Once you know what shape you have, you can choose the correct formula to find its area or perimeter. In problem 5, one of the things we're asked is what is the perimeter of the parallelogram? We want to find the distance around the outside. Because it's on a grid, we can count the squares. Vertically, it is 1, 2, 3, 4, 5, 6 squares. The right side of the shape will also be 6 units tall. Now the top and bottom of the shape. These are diagonal lines. We can't as easily count the squares, but we can find those lengths using either the distance formula or the Pythagorean theorem. Let's use the Pythagorean theorem. From point F, I'm going to draw downwards and then across to point G, creating a right triangle. This is 2. And going across is 5. The diagonal side that we're interested in could be given the letter C. We have 2 squared plus 5 squared equals C squared. This is 29 equals C squared. So C is the square root of 29. When finding the perimeter, we have the square root of 29 for the top and for the bottom of the shape. When you add those 4 sides up, that's the perimeter of the parallelogram. We're also asked for the area. The area of a parallelogram is found with the formula area equals base times height. The base of the parallelogram is 6 units, and the height of the parallelogram is 5. This is 30 square units. To get these two numbers, I'm saying that the base is this side right here, and that the height was this distance going across. Remember the topic from first semester where we rotated figures? Imagine in your mind that you rotate the parallelogram 90 degrees clockwise, then you'd be better able to see the base and the height. Next, let's move to number 6. Here we have a more complicated tabletop. This is a composite figure. It's built out of parts. Do you see the large rectangle piece? And do you see the parallelogram piece? We can find the total area of that figure by finding the area of each part and adding them together. For the rectangle, we would use the formula area equals length times width. That is 6 times 5, which is 30 square feet. For the parallelogram piece on the right, we would use the formula area equals base times height. For the base of the parallelogram, we could use either this longer side here, which is 5 feet, or we could use this side here, which is 3 feet. Which side you use for the base affects what number you use for the height. I'm going to choose to use 3 for the base. If I do that, then the height of the parallelogram is the length of this dashed line. We want to find that length, and we can do that with the Pythagorean theorem. This side right here is 5. This is the letter C. This across here is 3, and it's the letter A. The one that we're interested for the height, we could call lowercase b in the Pythagorean theorem. So 3 squared plus b squared equals 5 squared. B squared equals 25 take away 9, which is 16. Therefore, b equals 4. The lowercase b in the Pythagorean theorem is what we were calling the height of the parallelogram. This is 4 in here. So this makes 12 square feet. The total area of the tabletop is 30 plus 12 equals 42 square feet. Now the company could multiply by $8.50 to find out how much to charge the customer. So to summarize, we looked at two area formulas. Area of a rectangle is length times width, and area of a parallelogram is base times height. We also discussed perimeter of a figure, add up around the outside. Area is measured in square units, but perimeter is measured in regular distance units. We also discussed how to find unknown measures. You often use the Pythagorean theorem. Finally, we talked about composite figures, which are built of more than one component. To find the area of a composite figure, find the area of each component and add together.